Imagine this moment. Dinner is over, the table is quiet, the house is calm. But inside your body, a silent emergency response has just begun. Within minutes, glucose from your meal is entering your bloodstream. Not slowly, not gently, but in a steady surge. Milligrams every minute. Your pancreas senses it immediately. Insulin is released like an alarm signal. Muscles decide whether to respond or stay idle. Fat cells wait for instructions. Blood vessels brace for impact. And here is the part almost no one talks about. In the next 10 minutes, without realizing it, you are about to make a decision that changes how your body handles sugar, stress, inflammation, and long-term disease risk. Most people think walking is just about burning calories, morning or evening, before food or after. It all counts the same, right? Science says otherwise, because walking immediately after eating does something fundamentally different inside your body than walking at any other time. Different hormones, different cellular switches, different long-term consequences. And a growing body of research now shows that 10 minutes at the right moment can outperform 30 minutes at the wrong one. To understand why, we need to go inside your body minute by minute and watch what actually happens after you eat. After a meal, your bloodstream becomes a highway flooded with glucose. Within 30 to 60 minutes, blood sugar can rise from a resting level near 90 milligrams per deciliter to 180 or higher, even in people who consider themselves healthy. This is not just a number on a lab report. Each spike creates oxidative stress. Reactive oxygen species damage the delicate endothelial lining of your blood vessels. Think of it as microscopic corrosion, slowly weakening the system that delivers oxygen to your brain, heart, and organs. Large population studies show that post-meal glucose spikes predict cardiovascular disease better than fasting glucose alone. They correlate with cognitive decline, they track with future dementia risk, and they quietly raise HbA1c, the 3-month average marker strongly linked to mortality. This happens even in people without diabetes, especially in people who sit still after meals. But your body is not failing. It is responding exactly as designed, and muscles play a far bigger role than most people realize. Your muscles are not passive tissue. They are one of the largest glucose-handling organs in your body. Each muscle cell contains specialized transport proteins called GLUT4. Under resting conditions, these transporters stay hidden inside the cell. Insulin can bring them to the surface. But there is another pathway, a faster one, a more powerful one. Muscle contraction. When muscles contract, even gently, they activate an energy-sensing enzyme called AMPK. This signal tells GLUT4 transporters to move to the cell surface immediately. No insulin required. Thousands of microscopic doors open at once. Glucose is pulled directly out of the bloodstream and into muscle cells like a vacuum. This mechanism evolved as a survival system. When movement follows food, the body assumes energy is needed now. When movement does not follow food, the body stores energy instead. This is the fork in the road. Let's look at the first scenario, walking before eating. You wake up after 10 to 12 hours without food. Insulin is low. Liver glycogen is partially depleted. Cortisol and glucagon gently rise to maintain blood sugar. When you begin walking, muscles demand fuel, but no new glucose is arriving, so the body turns inward. Hormone-sensitive lipase activates. Stored fat is released as free fatty acids. Mitochondria shift into fat-burning mode. Over time, this improves metabolic flexibility, the ability to switch between fuels efficiently. Studies consistently show higher fat oxidation during fasted exercise. Over weeks and months, mitochondria adapt. Fat-burning capacity increases. Insulin sensitivity improves. But there is a trade-off. Fasted exercise raises cortisol. For well-rested, metabolically healthy individuals, this stress is adaptive. For those who are sleep-deprived, chronically stressed, or hormonally imbalanced, it can backfire. Elevated cortisol promotes visceral fat storage and blood sugar instability. This is why intensity matters. Gentle walking supports metabolism. Aggressive fasted training can undermine it. Now let's rewind and choose the other path. You finish a meal. Digestion begins immediately. Carbohydrates are broken down, and glucose starts entering the bloodstream in a rising wave. Your pancreas reacts fast. Insulin climbs, signaling cells to clear sugar from circulation. If you remain seated, your muscles stay metabolically quiet. They do not need energy, so insulin must work harder. Glucose lingers longer in the blood. Levels rise higher. Inflammatory signals increase, and vascular stress begins to build. But if you stand up and walk within minutes, the system shifts. Muscle contractions activate AMPK. GLUT4 transporters rapidly move to the muscle surface. Glucose is captured as it arrives, redirected into working tissue. Instead of a sharp spike, blood sugar rises gently and settles sooner. Insulin stays lower. Oxidative stress drops. Blood vessels are protected. This is not theory. It is measurable human physiology in motion. In 2025, researchers published a tightly controlled metabolic study designed to answer a simple but overlooked question. Does timing matter more than duration? Healthy adults were tested under 3 conditions: sitting still after consuming glucose, walking for 30 minutes, starting 30 minutes later, and walking immediately for just 10 minutes. The results surprised even the research team. The 10-minute walk performed right after eating produced the lowest glucose area under the curve, the lowest average blood sugar over 2 hours, and the lowest peak glucose, the spike most strongly linked to vascular damage. The longer walk done later helped, but not nearly as much. The reason was timing. Once blood sugar spikes, cellular stress has already begun. Walking later acts as cleanup. Walking immediately acts as interception. Participants also reported lower perceived effort and no increase in gastrointestinal discomfort. Gentle movement did not impair digestion, it supported it. For decades, people were told to stay still after eating. The concern was cramps, reflux, or disrupted digestion. Rest was framed as protection. Modern research tells a different story when the movement is light. Gentle walking activates intestinal peristalsis, the rhythmic waves that move food through the digestive tract. It supports gastric emptying, reduces bloating, and prevents that heavy, sluggish feeling many people experience after meals. The key is intensity. This is not exercise. It is movement. A slow stroll, a loop around the block, walking while talking, breathing, thinking. Light activity keeps blood flowing without pulling it away from the stomach. Your digestive system did not evolve for chairs and couches. It evolved alongside motion. When walking after meals becomes a daily habit, the body begins to change at a deeper level. These are not short-term effects. They are structural adaptations. Muscle cells increase mitochondrial density, improving their ability to use energy efficiently. Insulin receptors become more responsive, requiring less insulin to manage the same glucose load. Over weeks and months, HbA1c levels gradually decline, reflecting smoother blood sugar control across the day. Markers of cardiovascular risk improve, and emerging evidence suggests benefits for brain health and cognitive resilience. Large meta-analyses show that even 2 to 5 minutes of light walking after meals can significantly reduce postprandial glucose and insulin responses in adults with obesity or insulin resistance. This is not about discipline or willpower. It is about alignment with human physiology. In Japan, public health researchers examined 26 long-term cohort studies to understand how small changes in daily movement affect health across a population. Their conclusion was striking. Adding just 10 minutes of physical activity per day reduced overall mortality and dementia risk by more than 3%. This evidence helped launch the National Plus 10 campaign, built around a simple idea: add 10 minutes, anywhere, anytime. What recent metabolic research now clarifies is where those minutes matter most. Placing them immediately after meals aligns movement with the body's highest glucose load, turning a small habit into a powerful intervention. Not harder, not longer, just better timed. Your body is not broken. It is not sabotaging you. It is responding intelligently to the signals you give it. Walking before eating tells your body to access stored energy. Walking after eating tells your body to use incoming energy. Both are acts of cooperation. You do not need a gym. You do not need special clothing. You do not need willpower. After meals, stand up. Walk gently for 10 minutes. Before breakfast, optional. Listen to how your body responds. This is sustainable. This is humane. This is how biology was designed to work. If this changed how you think about movement, consider pressing like. If you want more calm, evidence-based science without hype, subscribe. And in the comments, share your experience, your own, or something you've noticed in your family. Someone reading may need your story. Your body is smarter than you think. Let's start working with it.